Hello, welcome back. Today we're going to talk about how to solve polynomial equations. So in previous videos we discussed the idea of solving quadratic equations. Now we're going to start talking about how to solve equations that are not quadratics but have higher powers. If you're following along in the Glenn Algebra 2 textbook, 2018 edition, this is in section 4.6 on page 274. So first thing we want to talk about is the formulas behind rewriting the sum and difference of cubes. So we know from, again, quadratics that the difference of two squares, a squared minus b squared, was just simply a minus b and a plus b. Well, we have similar formulas for the sum and difference of cubes. If we have a cubed plus b cubed, it works out to be a plus b, and then a squared minus ab plus b squared. Where if it's a cubed minus b cubed, it's the same exact format, and just add a minus sign here, a minus b, and then a plus sign for the ab term. So make sure you know both those formulas. That is something you need to make sure you have memorized so you can work it out. So if we want to factor the polynomial as far as possible, we need to see, well again, as always, what do they both have in common? So currently we are subtracting two expressions. Neither one is a perfect square, and neither one is a perfect cube. However, we know both terms have a 5y in common. So I can take out 5y, which if I take out a 5y, that leaves y cubed in the first term, and then minus a 64z cubed for the second term. We now see that this second term, the y cubed minus 64z cubed part, is two perfect cubes. Y cubed is perfect, 64 is perfect, and so is z. So we can now rewrite that part as the difference of two cubes. So it's important to identify what the a and b values are to plug back into that equation. So we know the a cubed is the first term, so that matches with y cubed. So that's very straightforward. That means just y will replace our a values. The other term is the b cubed part. So b cubed is 64z cubed. Well, that means b is, well, what number cubed gets a 64? That would be 4, and then it would be z. So I can now rewrite that y cubed minus 64z cubed expression, since it's a difference, as a minus b, so y minus 4z, times a squared, plus a times b, plus b squared. So just a plus 16z squared right there. And that's our final answer. The nice thing about the sum and difference of cubes is the fact that once you factor out the cube or the square, the resulting quadratic piece, this trinomial over here, can't go any further. The only way that the first term can go further is if the resulting part is a difference of two squares, or if it was still a difference of two cubes at that point, or a sum. Alright, so again, we always, when factoring, always factor out what we have in common from everything first. And then from there, we go ahead and rewrite it as the difference of two cubes in this case. So for this one, we take a look at it again. Can we factor this? Well, 8f cubed, 5g cubed, nothing in common. And while it is true that 8 and f cubed are perfect cubes, so we have an a cubed there, and g cubed is perfect, but 5 is not. So this is not a sum of two cubes. So this can't be simplified. So our answer is just simply 8f cubed plus 5g cubed. We can't go any further than that. Alright, so we take a look at this one. So we have negative 54w to the fifth minus 250w squared z to the sixth. So again, we're looking to see, okay, what do they both have in common? Well, number-wise, 54 and 250 both have a 2 in common. And since they both have negative signs, we're going to take a negative 2 out. And then we know it's w to the fifth and w squared, so they have a w squared in common. So if we do that, we're left with 27w cubed as the first term, and plus 125 z to the sixth as the second term. Well, we take a look at our numbers. 27 and 125 are both perfect cubes. And as far as the exponents go, as long as the exponent is a multiple of 6, it's a perfect cube then. So w to the third is a perfect cube, and then z to the sixth is also a perfect cube. So the first term represents a cubed, that's 27w cubed, which means a would just be 3w. And then the second term is b cubed. So 125z to the 6th would be b cubed. That means our original value of b is just 5z squared. So we're now going to plug that into our formula and rewrite the 27w cubed plus 125z to the 6th. Well, since it's a sum, it's a plus b, so 3w plus 5z squared, and then a squared, 9w squared, minus a times b, so 15wz squared, and then plus b squared, so 25z to the 4th. And that's as far as that expression can go. All right, so always keep in mind the rules for the sum and difference of two cubes. Always be looking for that. Even if it's not right in your face immediately as a sum or difference of two cubes, always try and factor if they have anything in common first, and maybe it will show up after the fact. Now, higher order equations, some of them are actually in what we call quadratic form. This is where we can rewrite the original expression as au squared plus bu plus c, where this u variable is some expression of x. For example, it's possible we take a look at 12x to the 6th plus 8x cubed plus 1, and we see that this is actually a quadratic form. The way you'll know it's a quadratic form is if the middle term variable, if you square it, gets you the first term variable. If you were to square x cubed, you get x to the 6th. Automatically, it's a quadratic. Now, to write it in simplest form, what you do is you take a look at the factors of the coefficients. So 12 breaks down into 2 times 2 times 3, whereas 8 breaks down into 2 times 2 times 4. Now, by the nature of the problem, what we're looking for now, number-wise, is, okay, so they have 2's in common. There are 2 2's for the square term, so I'm only taking 1 2. I don't know why I wrote 2 of them there. Sorry, there should have been 3 2's there. Not a 2, 2, and a 4. So we only want to take 1 2, though, from the middle term. Because remembering, we're squaring this value. That's how we know u is 2x cubed. Because we notice that, again, x cubed is the middle term. And then 2, there's only 1 2 they truly have in common, because if I take a second 2 from the 8, and I square that, I don't have enough 2's on the 12 side. So we need to have double the number of the factors in the leading coefficient versus the middle coefficient. And that will make a little more sense as you go through it. Ultimately, you can still solve this correctly, even if you just rewrite the x cubed as u, and just make this 12 u squared plus 8u plus 1. You can still solve that as a quadratic and get ultimately the same answer in the end. So if you're unsure of how to rewrite it the simplest form, u is 2x cubed, then just simply rewrite the x cubed as u and just leave the coefficients alone. So if we take a look at this term, we have 18x to the 4th minus 21x squared plus 3. So we notice the middle term is x squared, and then if we were to work with that in terms of the first term when it's x to the 4th, we then have it as a perfect square. So what we want to do now is we want to take a look at, okay, what are the factors of 18? So 18, oops, that's weird, hold on. Sorry about that, I was having some issues with the pen. There we go. So for factors of 18, well, we'll have a 2 and then 2 3's, whereas the factors of 21, we'll have a 3 and a 7. So we notice they have a 3 in common, and there are 1 3 in the middle term, and there's 2 3's in the second one. So that means we can say u equals 3x squared. Because that allows us to now rewrite the first term. Since we're squaring the u, that's when we need to have double them. This is really just 2u squared minus 7u plus 3. We can now solve the resulting quadratic. So when you go through in the actual factoring methods, again, you should use your grouping methods. I'm just going to kind of skip ahead for simplicity's sake for the video. We'll see that we have a 2u, a u, minus 3, and minus 1. when you actually go through the full foiling, reverse foiling process, which means u equals 1/2 and u equals 3. But we want to solve for x. So what we now need to remember is that u equals 3x squared, so we need to say 3x squared equals 1/2, and that 3x squared equals 3. Because we need to actually get x. So for the first one, divide by 3 and get x squared equals 1/6, which when we do the square root of that, x will give us plus or minus radical 6 over 6. Remember, we have to rationalize, so we would have 1 over the square root of 6, so we can't leave it like that. Whereas the other one, we divide by 3 and get x squared equals 1. So when we do the square root there, x equals plus or minus 1. And those are our two answers. Again, you can ultimately get the same results if you do not try and set up u equals like 3x squared, for example. We just use u, just replace the x squared with u, we get 18u squared minus 21u plus 3. So this stage right here, we notice everything's got 3 in common, so we can divide by the 3, make it 6u squared minus 7u plus 1. And if we try to do our reverse foiling now, you'll see you have 6u minus 1 and u minus 1. So u equals 1/6 and 1, which ultimately is going to give you the same answer, because we said in this case u equals x squared. So x squared equals 1/6, same as we had up top, and x squared equals 1, same as we have up top. So ultimately it's up to you. You might find it easier to just rewrite the x squared as u, and then solve that quadratic. If you can think of a number that they both have in common when you square it as well, again, recognizing you have to have double the number of factors in the leading coefficient versus the middle term, great. If not, don't worry about it. Same answers. So we have this one, 8x to the 4th plus 10x squared minus 12. Actually, first thing I'm going to do here is recognize everything is divisible by 2. So we'll make it 4x to the 4th plus 5x squared minus 6. So for this one, if we take a look at the leading coefficient, factors are 2 and 2, whereas the middle term is just simply 5. They have nothing in common, so in some cases, all we can do is just say u equals x squared, and that's it. So it becomes 4u squared plus 5u minus 6 equals 0. So again, if we're looking to try and reverse foil it, we will find that we're going to use, let's see, 4u and u, or the 2 will go here and the 3 will go there. Yeah, there we go, because this will make 8u and then 5u. Sorry, 3u, which subtracts to be the 5. So we'll make sure this is the plus and this is the minus. And that would be the proper way to reverse foil it. Again, go through the full process if you have to. You can use a guess and check process if you were comfortable with. Like I said, I'm not going through the full example there. If you need to review the videos on solving quadratics, number in front, please refer back to those videos, solving quadratic equations. Either case, u equals 3/4 and negative 2. So since u equals x squared, we have to say x squared equals 3/4 and x squared equals negative 2. So when we do our square roots, we'll get x equals plus or minus radical 3 over 2 for the first answer. And the second answer, because it's doing the square root of a negative, x equal plus or minus I square root of 2. So those are our answers there. So again, try and keep in mind the different rules we've always talked about for solving equations. Divide by a number they all have in common if that exists. And then part of the quadratic factoring, if you can recognize that there are double the number of factors for the leading coefficient versus the middle one, you can use that to rewrite the x squared as a u. If not, just set u equal to x squared and solve out that particular quadratic. Alright, one more. So we have x to the 4th plus 7x squared minus 8. Well, the leading coefficient is 1, so there's no hope for anything besides u equals x squared. So this becomes u squared plus 7u minus 8 equals 0. So this is definitely a much nicer one to try and factor. We'll get u plus 8 and u minus 1. Which means u equals negative 8 and positive 1. So if we say x squared equals negative 8 and x squared equals 1, we can solve those two equations. First one will be plus or minus 2 I square root of 2 when you simplify the square root of 8. The other one is just plus or minus 1. Square root of 1 is 1. Alright, so that's the idea behind solving quadratic form equations. Technically, these can be solved using the quadratic form or completing the square after you rewrite in terms of u. We're not going to get to nearly that level of complexity. We're just going to stick with it. They can still be factored afterwards, and then we're going to practice that. Alright, so always look for this if you can recognize that the middle term is exactly the square root of the leading coefficient in terms of the variables. And then if you look for the coefficients, great. If not, as you saw the last two examples, we didn't even need to worry about it, so don't stress over it. Alright, so thank you for watching, and I will see you next time. Sorry.